Oumuamua, this strange object that was discovered 2017, don't quite match what you expected, and you're trying to find an explanation. It moved too fast to be bound to the sun. Very first object that we have found coming to us from interstellar space, from other...
In July 2025, NASA's Atlas survey in Chile spotted 3I Atlas, only the third confirmed interstellar object after Oumuamua and Borisov. For Avi Loeb, it's proof he was right all along. These visitors can be risky, and this time we saw it coming early. Discovery details. The discovery of 3I Atlas was quiet, and almost no one outside the astronomy world noticed at first. On the 1st of July 2025, NASA's Atlas Survey telescope in Chile.
3I Atlas was discovered on July 1st by the NASA-funded Discovery using their telescope at Rio Hurtado in Chile.
Picked it up during a routine scan of the sky. There was no big press release or wave of headlines. It started like so many other small space object discoveries, a faint dot of light marked and saved for later study. At the start, 3I Atlas looked like an ordinary comet from our own solar system. Through the telescope, it showed a soft glow and a thin tail. That suggested it was made of ice and dust that was slowly turning into gas as it got closer to the sun. For the scientists tracking it, this was normal. Every year they find many objects that seem similar. Most are watched for a short time and then fade into the background once their paths are understood. But this object moved in a way that felt unusual. Over the next few days, the tracking data showed its path was not like the loops planets and comets usually follow. Instead, it was moving on a hyperbolic path, a stretched curve that would take it past the sun only once before it headed back into deep space forever. That told scientists it had come from another star system. With this, 3I Atlas became only the third confirmed interstellar object after Oumuamua in 2017 and Borisov in 2019. The way this discovery was received was very different from those earlier ones. Oumuamua became famous almost overnight. It led to debates all over the world when Avi Loeb suggested it could be an artificial object. Borisov also made headlines as a true comet from another star, with a bright and active tail that caught the eye of many observers. 3I Atlas did not get that kind of attention. The timing played a role. When it was first seen, many scientists and news outlets were focused on other space events. It also looked fairly normal compared to the dramatic shapes and activity of the earlier interstellar visitors. Still, this find has one important advantage. We saw 3I Atlas much earlier in its journey. That means there is more time to watch it closely and gather information before it disappears into the dark again. For people like Avi Loeb who warn about the dangers of such objects, that extra time is a big win. But finding 3I Atlas early was just the beginning. What scientists discovered about its speed and path would change everything. Physical characteristics. 3I Atlas is moving through space at a speed that is hard to imagine. It is traveling about 60 kilometers every second. That adds up to more than 216,000 kilometers in an hour. This is roughly twice as fast as Earth moves around the sun.
I-3 Atlas. That is plenty fast to pop into and then easily escape the gravitational pull of the sun.
With that kind of speed, it will pass through our solar system in only a few months before heading back into the deep darkness between the stars. Its path is hyperbolic. This means it is not going in a loop around the sun like planets or normal comets. Instead, the path is a stretched curve that shows it came from somewhere far beyond our solar system. Long ago, something must have thrown it out of its home star system. Now it is on a single pass through our part of space. The closest point to the sun, called perihelion, will come between the 29th and 30th of October 2025. At that time, it will be moving at its highest speed and showing the most visible activity. This will be the best chance for scientists to study it in detail. When astronomers first saw 3I Atlas, they noticed it had features that looked like a comet. It showed a faint hazy coma, which is a cloud of gas and dust around the solid core. There might also be a small tail forming as sunlight warms the surface. That heat turns ice inside the object into gas, which escapes into space. This process is called outgassing and is very common for comets. It also happened with another interstellar visitor, Borisov. Right now, Estimates suggest 3I Atlas could be as wide as 20 kilometers. Many scientists think it is probably smaller. Measuring the size is tricky because the glowing coma can make it appear larger than it truly is. As it gets closer to the Sun, its brightness and activity will change. That will help astronomers make better guesses about its actual size. The makeup of 3I Atlas is still a mystery. We know it is releasing gas, but we do not yet know which chemicals are present. Scientists plan to use a method called spectral analysis. This means splitting its light into different colors and looking for patterns that match certain materials. This can reveal if it holds water ice, carbon compounds, or other interesting substances that might give clues about where it came from. With 3I Atlas racing toward the Sun at incredible speed, the question remained: how does it compare to the other mysterious visitors we've seen before? Comparison with previous interstellar objects. 3I Atlas is only the third confirmed visitor from another star system. To understand its place in this rare group, it helps to look back at the first two. The first was Oumuamua, spotted in 2017. It had a long, narrow shape that some compared to a cigar. Unlike most comets, it showed no tail or hazy coma. Even more puzzling, it sped up slightly as it moved away from the Sun. This extra push could not be explained by gravity alone. Some scientists thought it might be caused by gas escaping from the surface, but no gas or dust was detected. Others, like Avi Loeb, suggested it could even be an artificial object. The mystery remains unsolved. Unfortunately, Oumuamua was already on its way out of the solar system when it was discovered.
An object that has come from beyond our solar system.
So there was no time for a proper, detailed study. The second was Borisov, found in 2019. This one behaved much more like a typical comet from our own solar system. It had a bright coma, a clear tail, and a chemical makeup similar to comets we already knew. Observations showed it contained water ice and carbon-based molecules, which supported ideas about how planetary systems form in other parts of the galaxy. Because Borisov acted like a normal comet, it did not cause the same level of debate as Oumuamua, but it still gave scientists valuable data. 3I Atlas appears to fall somewhere between these two earlier visitors. Like Borisov, it shows comet-like features, including a faint coma and possible tail. However, the activity so far seems weak, with only a small amount of gas and dust being released. It does not have the extreme, unexplained behavior of Oumuamua, yet it is not as active and bright as Borisov. The most important difference is timing. 3I Atlas was spotted months before its closest approach to the Sun. This gives scientists a full observation window from early approach through perihelion and into its departure. That is a huge advantage over Oumuamua, which was already leaving when it was noticed. Early detection also means more chances to gather detailed images, track changes in its activity, and study its composition using powerful telescopes. Unlike the puzzling visitors before it, 3I Atlas offered something completely new: time. But how did we suddenly get so good at spotting these cosmic travelers? Observational timeline and opportunities. The discovery of 3I Atlas early in its journey gives scientists a rare and valuable chance to watch an interstellar object from start to finish. Because these visitors travel so fast, they usually appear and vanish before we can study them in depth. This time, the timeline is clear, and every stage brings its own opportunities for learning. Right now, in August 2025, 3I Atlas is already visible to large professional telescopes and some powerful amateur setups in the southern hemisphere.
Astronomers looking through telescopes in Hawaii, a long dark object was racing through our solar system.
Through August and September, it will be in the best position for long observation runs. These months are perfect for collecting images and tracking its brightness to see if activity increases as it gets closer to the Sun. Early readings on its coma, tail, and rotation rate will help build a complete picture of its behavior. The most exciting part of the timeline comes in late October 2025. Between the 29th and 30th, 3I Atlas will reach perihelion, its closest point to the Sun. Around this time, It will be moving at its fastest speed and could show peak outgassing. For comet-like objects, this is when the coma and tail often grow brighter and more active. Observing it then will be critical for spotting short-lived features or bursts of gas and dust that may not appear again. After perihelion, the object will begin moving away from the Sun, heading toward the edge of the solar system. It will still be visible into December 2025, but it will fade quickly. This final stage is just as important as the approach. Changes in brightness and activity during its departure can reveal how the Sun's heat affects its surface and how quickly that activity stops once it cools down. One of the most important scientific tools during this entire period will be spectral analysis. By splitting the light from 3I Atlas into different wavelengths, scientists can identify the chemical fingerprints of gases and dust it releases. This will tell us whether it contains familiar materials like water ice and carbon compounds, or more unusual elements that hint at its origin in another star system. The data will also allow comparisons with Oumuamua and Borisov, helping researchers see whether interstellar visitors share common traits or vary widely in makeup. With months of advance notice, the global astronomy community can coordinate observations using telescopes on Earth and in space. If everything goes as planned, the study of 3I Atlas could become the most complete record we have ever made of an object from beyond our solar system before it disappears into the dark forever. Now that we can spot these objects months in advance, a bold question emerges. Could we actually send a spacecraft to meet one? Detection Technology Revolution. For most of human history, interstellar objects pass through our solar system without anyone knowing. Even in the early space age, our tools for spotting them were limited. Sky surveys covered only small sections of the heavens at a time. Much of the work relied on manual observation and photographic plates, which made finding small, fast-moving objects extremely difficult. By the time anything unusual was spotted, it was often too late to study it in detail. It is almost certain that many interstellar visitors came and went without a single recorded sighting. That situation began to change in the past 2 decades. Large-scale automated surveys started scanning wider areas of the sky, increasing the odds of finding rare objects. But even then, early systems lacked the sensitivity and speed to reliably detect fast movers from outside the solar system. When Oumuamua was found in 2017, it had already passed its closest point to the Sun. Borisov, in 2019, was detected earlier, but still only a few months before it left. Today, the landscape looks very different. Surveys such as Atlas in Hawaii and Chile, Pan-STARRS in Hawaii, and the upcoming Vera Rubin Observatory in Chile.
It was detected by a University of Hawaii-operated telescope in Chile.
Have transformed our ability to detect unusual objects. They scan huge portions of the night sky every clear evening, looking for anything that changes position or brightness. The data collected is far too vast for humans to check one image at a time. Instead, powerful machine learning systems process the images, comparing them to known star maps and flagging anything that moves in unexpected ways. This combination of constant wide-area coverage and automated analysis has made it possible to find objects like 3I Atlas much earlier in their journey. The system can spot even faint points of light that shift slightly between images, then quickly calculate their paths to see if they are coming from interstellar space. For astronomers, this is a revolution. Instead of reacting to a rare discovery after the fact, they can now prepare in advance. Telescopes around the world can be scheduled to follow the object at key points in its orbit. Space-based observatories can plan coordinated observations. By catching 3I Atlas months before its closest approach, these systems have given scientists their best chance yet to study an interstellar visitor from start to finish. This level of readiness was impossible only a short time ago, and it marks a turning point in how we explore the rare messengers from beyond our Sun. While visiting 3I Atlas might be impossible this time, its discovery hints at something much bigger happening in our corner of the galaxy. Mission possibilities and challenges. The discovery of 3I Atlas months before its closest approach naturally raises the question of whether we could send a spacecraft to meet it. Missions to intercept interstellar objects have been discussed before, especially after the mystery of Oumuamua in 2017. One of the most notable ideas was Project Lyra, a proposal to send a probe after Oumuamua using a series of gravity assists from planets to build enough speed. The goal would have been to catch up with it years after it left the inner solar system. The main challenge with 3I Atlas, and with any interstellar visitor, is speed. It is moving at around 60 kilometers per second, which is far faster than anything we have ever launched from Earth.
The stars are individual dots of light, and this object was a streak, so they knew it was moving fast.
To match that velocity, a spacecraft would need multiple gravity assists from planets, or possibly even a boost from advanced propulsion methods that are not yet ready for real missions. Planning such a complex route can take years, and the spacecraft itself would need to be designed, built, and tested before launch. Another factor is timing. We have only a few months between spotting an object like 3I Atlas and its closest approach to the Sun. Even with early detection, the window is far too short to develop and launch a brand new mission from scratch. The only way to respond in time would be to have a ready-to-go spacecraft already built and waiting, which comes with its own set of problems, including storage, maintenance, and costs. Intercept opportunities for interstellar objects are one-time events. If we miss our chance while they are in the inner solar system, they speed away into deep space forever. That puts extra pressure on both planning and funding. Space missions take years to design and are often limited by tight budgets and international coordination issues. Launching in such a short time frame would require bypassing much of the normal approval and testing process, which carries its own risks. Despite these challenges, some scientists argue that the increasing rate of detection means we should prepare a rapid response mission system now. This could involve building a modular spacecraft with instruments ready to be adapted for the next interstellar discovery. While expensive, it would allow us to act within days or weeks of finding an object, giving humanity its first chance to study one up close. For now, though, 3I Atlas will likely remain an opportunity for remote observation rather than a direct visit. As telescopes around the world prepare to watch 3I Atlas reach its closest point to the Sun, one thing becomes clear: we're living through a revolution in space discovery. Implications and future outlook. The discovery of 3I Atlas marks the third confirmed interstellar object in less than 10 years. This is a huge shift from what scientists once believed. Before 2017, we had never seen such an object, and many thought they would be extremely rare. Now, with 3 examples, Oumuamua, Borisov, and 3I Atlas, appearing in under a decade, it seems these visitors are not unusual at all. Instead, we may be passing through a steady stream of debris from other star systems that simply went unnoticed until recently. Better detection technology is almost certainly the reason for this change. Surveys like Atlas, Pan-STARRS, and soon the Vera Rubin Observatory can scan large areas of the sky night after night. This means faint, fast-moving objects are much harder to miss.
It's moving at a velocity of about 135,000 miles per hour, so it's going really fast.
If the current trend continues, astronomers expect more frequent discoveries, perhaps even several interstellar objects every year. The scientific importance of this shift is hard to overstate. Each new object adds to a growing catalogue that will help scientists understand what kinds of material are being thrown out of other solar systems. By studying their paths and physical features, researchers can learn how planetary systems form, evolve, and sometimes eject debris into interstellar space. Over time, we might even start to recognize patterns. For example, whether certain types of stars produce specific kinds of comets or asteroids. The more examples we find, the more interstellar objects will move from being strange anomalies to part of routine astronomy. This does not make them less exciting. In fact, regular observations would give scientists a chance to compare many different examples, spot unusual cases, and refine models of how our galaxy recycles matter between star systems. For the public, frequent discoveries could also change how we think about our place in the universe. Interstellar visitors are physical proof that our solar system is not isolated. Small pieces of other worlds pass through our cosmic neighborhood, and in rare cases, we can catch them in action. The next step is deciding how to take advantage of these encounters, whether through advanced telescopes, sample return missions, or even rapid intercept spacecraft. In the years ahead, as detection methods improve and more interstellar objects are logged, humanity may go from seeing them as rare mysteries to viewing them as regular messengers from the stars, each carrying clues about worlds far beyond our own. Before 3i Atlas vanishes into the dark, scientists will be watching every moment, uncovering clues about worlds beyond our sun. If you found this journey through interstellar space fascinating, don't forget to like, share and subscribe, and join us next time as we explore more wonders of the universe.